Hi everyone, good evening.
Good evening, sir.
Yeah, so if everyone, today we have to work on the deployment part. And second thing that what I can see, I had shared one Google sheet, and I told you that you people have to mention whether you're going to work on the classification or the regression, and I had shared the data set also. Okay, so you can take this, you can utilize this time to give your name as well as if anyone who has not given their name in this Google sheet. Okay, otherwise what will happen? I'll just compile it, and whoever has not given their name, I'll just update the Google sheet according to me. Yeah. Okay. So let me show you this deployment part. Okay. So first of all, please try to see that this is the folder. Hmm, where's the folder? Yeah, this is the folder, and so this is the folder that I'm talking about. And you see here we have this iris data. So this iris data that we have, this iris data we are having these four input features, and we have the output feature. So we have just built this model, and now let it deploy it. So deployment means what? Now this model will be capable of whatever input you'll be giving, any input you'll be giving, it will be doing its prediction. It will be doing its prediction. Okay. So for that, what we will do, say we have just gone to this Anaconda prompt. We've just gone to this Anaconda prompt. Okay. Then writing here the path where my app.py is deciding. Whatever these are, I'll tell you later on. But first of all, I'll just give you the path where my app.py is deciding. Okay. So that is inside this Upendra folder. There is the ML and all. Okay. Inside this, my app.py is deciding. So what I'll write here, I'll just write Python app.py. When I clicked on it, you see it is giving me one URL. I'll just copy this URL. I just copy this URL, go to the browser, and run it. You see? And here I'll be giving some value. Say that any value if you want to give. So I'll be giving the value in this range. Say that this is 6.2, 2.8, 4.8, 1.8. And when I'll be giving this feature 6.2, 2.8, 4.8, and 1.8, what will be the class? The class will be Virginica. The class will be Virginica. So yeah, 6.2, 2.8, 4.8, and 1.8. And when I'm clicking on this predict button, you see It is telling me that if these features are there, then what is the species? It is Virginica. What is the species? What is the species? Virginica. Okay. So this is how it's doing the prediction. Now the question arises how the things are going on. Yeah. How the things are going on, we'll have to see it. So let me take this screenshot and so see how we have done it. Try to understand. And I'm really sorry, I forgot that today I had to complete this ANN, but no worry, we'll do it tomorrow. Okay, we'll do it tomorrow. And because, that requires some time. But anyway, if I'll be getting the time today, I'll do that, no issue at all. So here you see what is happening. So first of all, you require one HTML file. And in that HTML file, you're going to give this input. Yeah, that means this format, this page that you have designed, just to design this, you have to take the HTML file so that a user can give the value over here. And in addition to this, in this HTML file, you will have one button. When the user will be clicking on this button after giving the input, it should be giving you the output. And what happens when you click on this predict button, your model is called. Your model is called, and this model is actually converted into model.pickle. This model is converted into model.pickle file, and this pickle will be called. And when you would have called this model.pickle, your model will be calling this predict function. And here, all these values, they will be passed just like you were passing the x_test. And it will be giving the prediction. Okay. So whenever you need to deploy it, you require app.py. This app.py will be integrating, it will be having both the HTML file as well as that model.py in terms of model.pickle. You require this app.py, and this HTML will be residing where the folder inside this app.py is residing. Inside that app.py, there will be another folder named as template. Inside this template, you will have the index.html file. And in this folder, you will have another folder named as a static. In this static, there will be another folder that is the CSS folder. And inside this CSS, you'll be keeping your CSS file. This CSS is used only to just give you the lucrative presentation, the lucrative look of your file. Otherwise, even if you're not using this static, it's still no issue at all because your HTML file is there, and what is your requirement? Somewhere, somehow, you should be able to give the input. So this is the thing that you want. Now let me summarize it. So basically what will happen, first of all, you'll have the folder. Whatever name of the folder is there, you can do. In my case, it is that ML model and all. Inside this, what will happen, you'll have two folders. One is the static. Inside this static folder, you will have another folder CSS. And inside this CSS, you'll have .css file. And you will have another folder. This folder will be what? This folder will be template folder. Inside this template folder, you will have the index.html file. Okay, and you will have this app.py. You will have this model.py. Now I tell you right now, whenever you'll be running this model.py, after running this model.py, as I told you that you'll be having this pickle. So when you will be running this model.py, the pickle file will be created in your current working directory. You will just keep that model.pickle also in this folder. You see? So these are the things that you have to maintain, just like I'm showing here. So this is my folder. There's another folder, static. Inside this folder, there's a CSS. And inside that CSS, we have the CSS file. Inside this, there is a template folder. And inside this template folder, we have the index.html. And then we have this app.py, the data set, the model.pickle, which is actually, when we had run this model.py, it was converted. It was converted into pickle file. Now, see here. So this is my app.py, this is my model.py, and this is my index.html. Let me show you first this index.html. Yeah. In this index.html, what is happening? You see, these are the style sheets. So even if you don't use, no issue at all, I show you this one. So you're just using a form. Inside that form, you have the 4 text field. And what is the job of this text field? What is the job of this field? You just are going to give the input inside this HTML file. Okay. For that purpose, we have used this 4 input field, the text field. And then after, you see, you had one predict button. You had this predict button. And this is what, this is your submit. So these 5 things you require in this case. Suppose in your case, you have 6 features. In your case, there will be 6 features. So what will happen? Instead of this 4, you will be creating 6. Instead of this 4, you will be creating the 6. So this is my HTML file. And you see one thing another. You are providing one space here where whatever prediction your model will be doing, it will be shown here. Whatever prediction your model will be doing, it will be shown here. So this is your HTML file. Now, let's see this model.py. So just like you had built the model earlier, in the same way we are just reading each and everything. Only one additional library we are importing, that is pickle. Okay. So we are just reading the data, we are doing the data cleansing, we are standardizing the data, we are building the model, we are training the model. And you know, see, whenever we work on the project, as I have told you that we'll be trying with the multiple models. And whichever model will be doing best, we'll be using that model. Say that in our case, this random forest model was the best model we have done. We have used this random forest model. It is performing the best. So that means what? This random forest model is my final model. So what I'll do now, I'll just finalize it and I'll dump it into the pickle file. So this is classifier is my model. It is holding the random forest classifier. So I'll just dump this classifier into what? Model.pickle. And that's why I've just called this pickle.dump. Classifier is the name of the model where you have the model, and then we'll be dumping it into a model.pkl file in the write mode. Yeah. And if I run this, see, and what is my current working directory? This is the C users open. Okay, might be that you are already working in the current working directory. your all folders are in the current working directory. So in case of me, it is inside the C. There's a users. There's open. So when you will go there in this C, users opened. So can you see, guys, this model.pickle? You see, right now we have traded it 734. It is showing you. We'll just cut it from here and we'll paste it inside this folder. Okay. Now, if I show you this app.py, in this app.py, first of all, you see, we are just loading this pickle file. That was the model.pickle. And you see, we are using this render, this slash. This slash. So here you see that all the roots will be given by the forward slash. And first of all, what we are calling this index.html. Yeah, means when we'll be deploying it, the first page will be looking, and that will be the index.html. And when you'll be clicking on this predict button, what is going to be there? You see, this predict button, you have shown the URL. This predict function will be called. So when the predict function will be called, first of all, what will happen? Whatever 4 values you have given here, whatever 4 values you have given here, they are in the object form. They will be in the string type. And that is why they will be converted first into the float. So one by one, we'll be getting the value from the HTML file form, and then they'll be converted into float. And all these float 4 features will be kept inside what? This float underscore features. And then we are converting them into array. Why? Because if you remember, when we were using this x underscore test, it was having the multiple value in terms of the array, like the array. And that's why whatever values we are getting here, we'll be converting them into the array. And then this predict function we have called, and this predict function will be working on these features, which is containing the array of the new input. Yeah. And see, whatever prediction it will be doing, it will be shown where? Through format function inside the curly braces. And where is this curly braces? That one. I show you. That's one. So here it will be shown. So if you see, guys, the same thing I have done. Yeah. And how it will be run, I have shown to you. I have told you. I hope that is understood, everyone.
सर model.py फिर से रिपीट करिएगा वन टाइम.
model.py जो है वो आपका नॉर्मल, जैसे मैंने आपको बताया था ना, मशीन लर्निंग के प्रोग्राम्स आप रन करते हो,
यस सर.
उसी तरीके से आपको करना है. बस बाद में क्या करना था दोस्त, आपको उसको पिकल में डंप करना था. क्यों? क्योंकि ये जो app.py है, ये app.py इसी model.pickle को कॉल कर रहा है. देख रहे हो, है ना?
यस सर.
ठीक है, एक काम करते हैं, क्योंकि डिप्लॉयमेंट बहुत नेसेसरी है मेरे लिए. मशीन लर्निंग मॉडल्स आपने सभी ने यूज कर रखा है. सी व्हाट हैपेंस, although that is not in your syllabus, to be very frank and honest, this is not in the syllabus, but still what happens whenever you build the model, then after one question arises, I have done the model, next what? Just to answer this next what, I always add this deployment in my session, whether it is mentioned in the syllabus or not. So what I'll do now, and one more thing, guys, just to run this, Anaconda is required because I've taken the .py extension. So if you have the PyCharm, you can do that. Whichever platform you'll be using, that should be capable of dealing with .py extension. So if you have Anaconda in your system, that is very good. Otherwise, if you have PyCharm in your system, still it is very good. Okay, so and I'm just sharing you.
Okay, sir.
Okay, yeah. Let me start ANN, artificial neural network. So if I am not mistaken, yesterday we had discussed about the deep learning primer.
Yes, sir.
Okay, I had discussed about the deep learning primer, and the the perceptron that I have shown to you, that was just like this. Okay, this was there, and basically when it comes to the simple neural network or this perceptron, it will be capable when you will have linear problem. Means when the pattern will be the straight line. But whenever you'll have non-linear problem, then what will happen? This simple neural network, this perceptron will become fail. Okay, so just to deal with it, what we'll have to do? This is your output. This is your output layer, and this is your input layer. Between this output layer and the input layer, we'll be adding multiple. We'll be adding multiple layer. Okay, and that multiple layer will be what? Your hidden layer. Okay, so here, see, so what we will do in between the input layer and the output layer, we'll be adding multiple layer, and that will be called as hidden layer. Okay. Now, first question arises: how many hidden layer? See, there is no any place where it is written, but according to my experience, I am sharing with you guys that it should not be 4 to 6. Yeah. Now, so let me first of all draw this thing. So how we'll be doing that? Please try to understand. We have this input node. We have this input node. Okay. This is my x naught equals to 1. This is my x1. This is my x2, and this is my x3. Now what we will do? We will be having some layers. say that this one. Okay, and each node in these layers will have integration and the activation function. Integration and the activation function. Okay, first thing. So you see here that this is my input layer and this is my output layer. But in this input and the output layer, we have multiple hidden layers. See, 1, 2, 3. I have put it 3 hidden layers. Now what will happen? All the nodes in the layer n, all the nodes in the layer n will be connected to each nodes in the layer n plus 1. Means this input layer, all the nodes in this input layer will be connected to each node in the first hidden layer. Okay. All the nodes in the input layer will be connected to each node in the first hidden layer. All the nodes in the input layer will be connected to the each node in the first hidden layer. In the same way, all the nodes in the first hidden layer will be connected to each node in the second hidden layer. All the nodes in the first hidden layer will be connected to each nodes in the second hidden layer. All the nodes in the first hidden layer will be connected to each node in the second hidden layer. And then all the nodes in the second hidden layer will be connected to each node in the third hidden layer. All the nodes in the second hidden layer will be connected to each node in the third hidden layer. And then all the nodes in this third hidden layer will be connected to your output layer. Will be connected to your output layer. And that is your output. So this is your hidden layer 1, this is your hidden layer 2, this is your hidden layer 3, and this is your output layer. See, whatever connection you're seeing, they will have some weight. They will have some weight. So here you see that all the nodes are connected to every node in their next layer. That is why it is called as fully connected network. All the nodes that are there are multiple layers, and this is why it is also called as multi-layered perceptron. So whether you are telling fully connected network, whether you are telling multi-layered perceptron, actually they are what? They are the synonym of the artificial neural network. So this is just like a simple neural network, but what is the difference? The difference is that in the simple neural network, you had only the input layer and the output layer. But in case of this artificial neural network, you will have some hidden layer, some multiple hidden layers inside the input layer and the output layer. Okay. Second difference, that simple neural network was capable of handling only the linear problem, but your artificial neural network will be handling the non-linear problem also. Okay, everyone? Yeah. So each and everything that we had seen yesterday about the gradient descent output, each and everything will be applied here. Only the thing is that the difference is that we'll be having some hidden layer, some layers also. So let me open my Google Colab. Friends, please update this list if you want seriously to work on the project. I'll be just writing here Google Colab. Okay, for this purpose, what I'm going to do, I'll be using this file. So this is my Google Colab. How many of you have worked on the Google Colab? Please tell me now. Please let me know. How many of you have worked on the Google Colab? Okay. How many of you have not worked on the Google Colab?
So I haven't.
Okay, you have not. Okay. Sumit?
But I'm looking forward to
No,
because
sir.
I don't have a GPU.
Oh my God. No worries, Somnath. There are there are so many people. You're not alone. Okay. See. So this is just like a Jupyter. First thing you keep in your mind. So you just have to go to the Google. You just have to go to the Google and you'll be writing Google Colab. You'll press enter. This will be opening. There, you'll be clicking on this new notebook. And you see, this is just like a new Jupyter. Okay. Now, since you have already this Python file, you'll just go to the file, click on the upload, and you will upload the file. Okay. Now, please try to understand when you were working on the Jupyter, what was happening? The file you were taking from your local memory. When it comes to Google Colab, here you'll have to mount your Google Colab with your Google Drive. You have to connect your Google Colab with the Google Drive so that you can take the file from there. You can take the data set from there. So just to mount your drive, please have a look on this. You can see here the folder. Can you see, guys, this folder? I'm roaming my cursor around that. Please respond.
Yes, sir.
Yeah, you will click on this folder. Okay. First of all, you see, you will have to click on this connect so that a RAM can be assigned to your program. Now, you see, when you had clicked on this folder, you are seeing these options. You have this Google Drive option. Click on this mount drive. So this code will appear. You have to click. You have to run this. Either you can use the same option, shift enter or control enter, just like you are running in the Jupyter notebook, or you can click on this. Connect to Google Drive. So it will just ask that with which Gmail account you want to connect. I just select this one. Then it will be asking for permission. I'll click on this allow. Okay, so this drive has been mounted. This drive has been mounted. Now you see, you'll click on this runtime. There is a change runtime option, but friends, before mounting your drive, you have to do it. You just go to this runtime, click on this change runtime. You see, already in my case, this TPU is coming. Otherwise, in your case, it will be coming as none. You just have to select either GPU or TPU. And then you have to save. But in my case, it is already there, so I'll not do it. But in your case, it will be this none. You have to select either GPU or TPU. Getting my point? because whenever you will be working on the deep learning, GPU should be there in your system. And that is a very costly hardware. So that's why what we do, we just take the facility of the Google Colab. So what is the meaning of mounting? Now, this Google Drive will be acting as a local drive for my Google Colab. So obviously that file should be here. So just click on this drive. There's a My Drive. Now, we'll do one thing. We'll just create one folder here. So how can you create the folder? Click on this three dot of My Drive. Click on this three dot of My Drive. Okay. After clicking this, you see there's an option of new folder. When you click this, you see this untitled folder is coming. Right here, dataset 2. Right here, dataset 2. So you see, this dataset 2 is being created. Now, just go to this three dot. There's the upload option. Click on this upload. Say that this dataset I just want to upload. So I'll just click on it and open. You see, this dataset is being uploaded in this dataset 2 folder. You can just upload this into any existing folder also. Now I'll just go to this file. There's a three dot. We'll click on this three dot. There's a copy path option. I'll just copy it. Okay, I'll just copy it and we'll paste here. Where? This one. Okay. Then after you see, if you're going to use this TensorFlow for the first time, then you need to install it. You need to install it. Since I have already installed in my environment, so I'll not do it. But since whenever you'll be using first time, then you need to install it. Then after, this freeze is used to see whatever different libraries I have installed in my environment or it is present in my environment. Then we're importing this TensorFlow STF. From that TensorFlow, we are importing the sequential, dense, and MLP classifier. Yeah, but the thing is that we are working on the startup data, and in this startup data, we have to predict profit. And you know that profit is what? That is the continuous. That is the continuous. So what we will do, instead of this, we'll write here MLP regressor. I hope you understand why I have written here MLP regressor, because we're working on the regression. Yeah. Since you're working on the regression, then you don't require this confusion matrix. So you please write it as comment. Okay, let me import all these files. Next to this, let me read this data. So this data I have read this in this startup variable. Okay, you see total value we have 50,5, very short data, very small data we have. And if I see here, then there's a scaling issue in my data. So what I'll do, I'll just do normalization. So, second thing is that, do you think state will have any significance? So obviously not. So this third index we have discarded, and this is startup underscore new. We have all the columns except this third index column. You see? Now, we are just normalizing it. Okay, we are just normalizing it. You know why we are normalizing it? Then after, we are just importing this train test split. Now, in the X, we are keeping the normal data of input, and in the Y, we are keeping the output data. So this we are getting. And then we are splitting our data into train and test, and you see the train is proportion will be 80% and the test will be 20%. Okay. After that, 1 second, guys. Okay, everyone. Now, you see. So, let's design this model. Okay. You see, this is my input. We are using the sequential model, and this is my output layer. So if you see, what is my output variable here? Profit. And what is it? It is the continuous. And do you remember, yesterday I told you, whenever your Y will be continuous, then in the output layer, how many number of neurons will be there? Anyone? When your Y is continuous, then how many number of neurons will be there? Come on.
1.
1. What will be the activation function?
Linear.
Linear or ReLU. Perfect. And what will be the loss function? Mean squared error or
root mean square error.
Okay, dear. So you see here. So you see, and I told you that except output layer, in any layer, you can use any activation function. Okay, you can use any activation function. So, how many hidden layer I have used? Let me take the screenshot of it. Okay, this is there. Now see, first of all, we have taken our input 45,3 and see we had 50,3 in our total data. We just splitted it into train and test. So 40,3 is my train shape. Isn't everyone? 80%. So I'll be giving here 40,3. So in my input data, we have 40,3. Then after that, first hidden layer we have used. In this hidden layer, how many neurons are there? 150. And what is the activation function we have used? ReLU. In the next hidden layer, we have the 200 neurons. And what is the activation function? 10h. Then we have the another hidden layer. We have how many neurons? 100. Then what is the activation function we have used? 10h. Then we have another hidden layer where we have 1000 neurons. What is the activation function you are using? 10h. Then after you have this output layer, and you know, in this output layer, we are using the 1 in neuron, and the activation function will be using ReLU. So in the output layer, everything will be confirmed, everything will be fixed. Other than this here, you can use any number of neurons and the activation function. And see, since the last function, we have used mean squared error. Optimizer is actually your gradient descent algorithm. We have the option of the atom or the RMS prop. Yeah, or I think there is one more, I don't remember. So the question arises, on what ground we have taken this number of neurons? So I tell you, there's a formula. What is the formula? N by 2 plus 3 into n, where n is the total number of features you have. So suppose you have the 5 input column, so it will become 3 plus 3 into 5, 18. But you know, this number of neurons will become very less. So what we can do, Whenever we'll have less number of features, then we can randomly choose the number of neurons in the hidden layer. Otherwise, this will be the formula just to choose the number of neurons in the hidden layers. I hope that makes sense. Okay. Now, let me run this. So we have just defined this function, and we are calling this function into what? Into this model variable. So we have called this function in this model variable. Now, see, we are running this, we are training this model on my train data. How many epoch I have taken? 100. Default batch size is 32, but we are taking 5 only. So if the batch size is 5, the number of epoch is 100. So what will be the total number of iteration in each epoch? See, 40 upon 5. Why 40? Because in the train data, the total number of rows are what? 40. So 40 upon 5 will be what? 8. So let me run this. And you see, it is giving me the error. What is the error? Please try this. It is telling that the expected shape was none, 5, 3, and the found shape is 5, 3. So what we will do here, and guys, you know, what is the train shape of mine? Thirty comma 3, no? So I'll just give here the train data shape. So I'll just write here 40 comma 3. And you know, by default, your deep learning model, your ANN model work on 3 dimension. Since you're giving the number of rows and the columns only, so it will be the 2 dimension. Just to fulfill the criteria, just to make this as a 3 dimension, we'll be writing here none also. Okay. Now it has become the 3rd dimension. Okay. If I running now, you see it has started to work upon. Okay. So you see, when we have run this, the last function on this 40, we have taken 0.0022. So when you will be subtracting this by 1, means, you know, when you will be evaluating it on the test data, you'll be getting the scored error. When you'll be subtracting this by 1 and multiplying with the 100, it will be represented in the percentage. So what is the percentage we are taking? Getting 99.37. Let's evaluate on the train data in the same way. So we'll be calling this model.evaluate. We're giving the X train and Y train both, and then 1 minus your evaluation stroke. And we are running this. What is the train accuracy we are getting? 99.68. So the train accuracy is 99.68. The test accuracy is 99.37. What kind of model we have, everyone? It's a right-fitted model. Here, it's a right-fitted model. So in this way, we used to work with the artificial neural network. So guys, let's do one thing. We'll just stop here, and I'll share you the one more data set on which you have to apply this artificial neural network. Okay. And if you're stuck anywhere, then you can discuss tomorrow. Okay. So let me share you the Python file as well as the data. If you are stuck anywhere, then you can discuss me tomorrow. So till then, let's stop here, everyone. Thank you so much. Bye-bye. Take care.